Okay, welcome to example 1, 5.2. This wants us to sketch the graph of a function that's been transformed and then use language. And I think it is important that you don't have to approach this in the order of A through C. What I'm actually going to do first is C. And I think it is important that this takes us back to all the function transformation that we've applied or identified in the past. And it is maybe not simple, but what we're going to do here is identify that C is positive 30 degrees and D is positive 3. Now, if C is 30 degrees, we have a horizontal translation 30 degrees to the right because it's positive, just like any horizontal translation from previous chapters. And if D is equal to 3, we have a vertical translation of 3 up. That is the language that compares our graph to y equals sine x. If we want this function, y equals the sine of x minus 30 degrees plus 3, then we should take y equals sine x and move it 30 degrees to the right and 3 up. And we're going to do that to the points. But you've probably noticed by now that I really do like the mapping form. And so any point on y equals sine x is going to turn into x plus 30 degrees, comma y plus 3 on our graph of y equals the sine of x minus 30 degrees and then plus 3 after the fact. Now, to really exploit how wonderful function notation, or sorry, mapping notation works, is I'm going to grab what I would typically call the 5 critical or key points on y equals sine x, which is 0 degrees, comma 0, 90 degrees, comma 1, 180 degrees, comma 0, 270 degrees, comma negative 1, and then all the way back to that full rotation at 360 degrees, comma 0. Now, this is really important that you're able to picture, or use your calculator, whatever you need to do, the graph of y equals sine x without much trouble. And just kind of, if I was to label these points, this would be 1, this would be 2, 3, 4, and 5, we would have 3, 4, and 5 respectively. Now, if we can get those points and determine what they are on our new graph, then it does become connect the dots, which is kind of, maybe not easy, but as routine as we can make it. So that means that 0 degrees, comma 0 is going to turn into 30 degrees, comma 3, and then we'll have 120 degrees, comma 4. This will be 210 degrees, comma 3, and then 300 degrees, comma 2, and then finally 390 degrees, comma 3. Now, it is important, and that we can only indicate this as 1 point, that from 300 degrees to 3 and 390, this is 1 period. So we do expect the y value to be exactly the same. Now, what we can do with that information is we can take those 5 points and graph them. Now, our graphing space is a little bit limited. I have the same thing that you do, so it only goes up to 360 over here. We're going to cheat a little bit. 390 would be right there. So what I'm going to do is I'm going to plot those 5 points that we identified. So 30 degrees, comma 3. Let me just label this. This is 1, 2, 3, and 4. That's actually all we'll need because this graph is never negative. We also have 120 degrees, comma 4. That's up here. Then I have 210 degrees, comma 3. What's this? 300 degrees, comma 2. It's right here. And finally, and again, we could certainly just grab the point off of our information list, but I know that 390 degrees is a full period away from this point right here, which means it has the same y value. It's just a little bit outside of our grid. Now, if we connect the dots, then what our sine function looks like is something like that. Now, that is going to continue in both directions. Important that it does start to inflect a little bit here, but that's okay. We'll just draw that arrow. Now, that's what 1 full rotation looks like. And then what the rest of the question wants us to determine is the domain and range of this function. One thing that is going to be really useful, I think, even to start right now, is the idea of recognizing that this dotted line cuts my sine function in half, and it is y equals the d value, which in this case is y equals 3. All right, that looks a little weird to me. I'm going to write that underneath. Now, that is a pretty important consideration because what this does is shows us that the maximum point is the amplitude above y equals 3, and then the minimum is the amplitude below y equals 3. That guides us to our range. So we'll get the easy one out of the way right away. The domain of this function is x is an L into the real. If it wanted 1 rotation, we should put 360 degrees, but that's not what the question asked. The range is going to be that y exists. Okay, my lower bound, this right here, is 3 minus the a value, which was 1. And that's 2. Now you can certainly see that it's at the y equals 2 line on our grid, but that means that my lower bound is 2 and my upper bound is positive 4. That's right here. And that is at y equals the 3 plus 1. So that's at y equals 4. Remember, my amplitude was 1. So I went 1 above y equals 3 and 1 below y equals 3. Do not forget to put what the x and y variable are an element of. That is something important, and it's something that they are certainly going to look for when you're answering these questions.